Hi, today we are going to study IC engine. IC engine means internal combustion engine. So the main objective of engine is, this is TH, this is TL, very common thermodynamic diagram. The main objective of engine is it takes heat from the higher temperature source, release some amount of heat to the lower temperature source, and produces some mechanical work, which is QH minus QL, and we call engine efficiency as efficiency is always output by the input. Here input is the QH and output is W. So this is the schematic of the engine. Now what is mean the internal combustion engine? In internal combustion engine there is a slider tank mechanism, and in this slider tank mechanism, slider placed in a piston and combustion takes place in the cylinder, and due to the combustion and some reciprocating motion occurs into the cylinder, which produces the mechanical work. That's why this name internal combustion engine. There is another engine which is external combustion engine. This thing is used in the earlier year when steam engine rails are moving. There, instead of internal combustion in the engine, some external combustion occurs, and the energy from this combustion going to the engine. You might have seen that in the earlier movies, the steam engine driven by steam engine drives a train. So this is the external combustion engine, but here we will concentrate on the internal combustion engine only. Also, steam power plant is a external combustion engine because combustion occurs in the boiler which produces the heat. This heat runs the turbine. So this is one kind of external combustion engine. Remember these points. Now IC engine broadly divided into two categories. One is 4-stroke engine and another one is 2-stroke engine. And in 4-stroke engine it is of SI engine, spark ignition engine, and CI engine, compression ignition engine, and 2-stroke engine basically of SI type. There are some CI engine also, but nowadays this is not used, only SI engines. Now what is meant by 4-stroke and 2-stroke? I am starting from the very beginning. So this is a typical layout of any engine, any IC engine. So combustion, this is the place of combustion. So combustion takes place here, and due to this combustion some energy release which pushes this cylinder, this piston. So this is the piston and this is cylinder. So this pushes this cylinder, and this is the slider tank mechanism. Schematic is this. So when this moves, this directly run will push this crank, and this will try to rotate, and this shaft is connected to the gearbox, to the wheel, and due to this motion the wheel of the car rotates and the car starts to run. So this is the mechanism. Now in this case, if you draw the PV diagram, now in complete cycle, so 1 second is this cycle, means piston comes here, go there, and one rotation. Another is the thermodynamic cycle, which is say in arbitrary shape. I will discuss this thing later in great detail. So if in a one rotation, or rather say if one complete thermodynamic cycle requires 2 rotation of crank, 2 full rotation of crank, then it is known as 4-stroke engine. Why it is 4-stroke? Why the number 4? So 1 complete thermodynamic cycle equivalent to 2 rotation of crank. Now in a single rotation, so this is the slider crank mechanism. Now this is the 2 ends. When this tries to move like this will rotate. So first cylinder starts from here, go here, then come back here. So it creates 1 rotation. So 2 rotation means 4-stroke. What is defined by stroke? A cylinder starts from the end position and come back to the another end position. This is known as sometimes top dead center and bottom dead center, or sometimes it is known as left dead center and right dead center. So 1 stroke is the movement of the piston from TDC to VDC or LDC to RDC. So 1 complete thermodynamic cycle equivalent to 2 rotation of crank is equivalent to 4-stroke. This is for 4-stroke engine. Simply for 2-stroke engine, so this is 4-stroke engine. These engines are a little bit expensive and very efficient. 1 complete thermodynamic cycle equivalent to 1 rotation of crank equivalent to 2-stroke. So this is known as 2-stroke engine. First, SI engine. We have discussed in thermodynamics that when in a thermodynamic process there is some question occurs, we use TS diagram or TP diagram. But when there is no questions, the working fluid is only in the gaseous state, then we use the PV diagram. So for SI engine or this IC engine, we always use the PV diagram, pressure volume diagram. So for SI engine, so first the engine sucks the air fuel mixture due to some spark. SI engine stands for spark ignition engine. Now one spark plug is there, so it creates some spark. Due to this spark, so first this is a cylinder position, it moves like this. So this is a suction, this is exhaust. So this suction valve opens, fresh air charge comes into this place due to this movement of the piston. Then it compresses the mixture. As this mixture compresses, the temperature and pressure increases. Then spark plug creates some spark. Due to this spark, the mixture burn out, and which by this huge energy it tries to move this piston towards its end, which creates power, and in the next it exhausts the exhaust burn gas. So first is this line, means the suction stroke. So in the suction line, means it air charge comes into the cylinder. So now the position is like this. So basically this moment also indicates the volume and the pressure. Then so from 1 to 2, so 1 to 2 is suction stroke. Now we can't burn any charge without high temperature or pressure environment. So this piston, now at position 2, the piston here, now it moves like this. So it compresses the charge here. So this 2 to 3 compression stroke. Now a spark is produced in this system. So rapid change in volume without increasing pressure. Please remember why this is a straight line. So this 3 to 4 due to the spark, and this is not any stroke, because in 3 to 4 this piston is not moving. So 3 to 4 is due to the spark. Due to the spark, the rapid increase of pressure without changing the volume, because due to the inertia of the piston, inertia of the gas, it wouldn't able to change its volume, because if it wants to change its volume, it needs to act opposite to the inertia of this pistons. So that much time it never have, because it is a very rapid combustion process, rapid air release process. So instantly from this point to this point, pressure jump from here to here. You can see that the pressure increases. Then from this point to this point. This is, say this is 3 prime. So 3 to 3 prime spark. This is not any stroke because volume is not changing. Piston is not moving. Then 3 dot to 4 is the exhaust. Now my combustion particles are in this position, and this is a burn particle, burn gases. This has no energy content. So we need to exist. We need to throw this thing to the atmosphere, to outside the system. So this 3 to 4 depth is the exhaust. Sorry, not 3 to 4. 3 to 4 is due to the power. Just I repeat. Sorry for the mistake. From 3 to 3 dash and 3 dash, due to the combustion, it creates some energy, huge energy in the piston. Due to this energy in the piston, it tries to move in this direction. So 3 to 4 is the power stroke, and from 2 to 1 it is the exhaust. I repeat, 1 to 2 suck the air charge mixture, 2 to 3 it compress the mixture, from 3 to 3 prime due to the spark, rapid release of energy, so volume couldn't able to change, so only pressure increases, and due to the combustion it tries to move the piston. So 3 to 4 is the power stroke which creates mechanical power, and 2 to 1 is the exhaust of the burn gas. Just remember that from 1 to 2, 2 to 3, 3 to 4 and 4 to 2, except this cycle, we are giving energy, and in this we are giving energy to the system, but in this 3.4 cycle the engine creates some work done. So in 1 to 2, 1 to 2, 2 to 3, 3 to 3 and 2 to 1, all this 3 stroke and this spark, we are doing work done on the system, and in the 3.4 it is work done by the system. Ultimately this addition of this 3, 1, 2, 3 is less than this power stroke. The addition of the mechanical energy is less than the power stroke mechanical energy. So ultimately we get some amount of mechanical energy from one cycle. So this is one thermodynamic cycle, and you can see that the movement is, this is one suction, compression, then spark, then power, and then exhaust. So it moves 4 times in one thermodynamic cycle. So it's a 4-stroke engine. So what is the main thing? What we have learned? First, what is the difference between IC engine, the internal combustion engine, and external combustion engine? In the IC engine, the combustion takes place in the cylinder, and in the external combustion engine, combustion takes place outside the engine. IC engine generally used in automobile, aircraft, like scooter, bikes, and this external combustion engine is basically the power plant engine, Brayton cycle based engine, gas turbine engine, and in older days in a steam rail, this engine is used to produce the mechanical power, the steam driven rail. And then we classified that IC engine has 2 types, 4-stroke, 2-stroke. What is the 4-stroke mean? What is the 2-stroke mean? Now in 4-stroke engine, first we talked about SI engine. SI engine has 4-stroke. One is suction stroke, compression stroke, power stroke, and exhaust stroke. And what is SI engine? The name suggests we require a spark to ignite the charge, air and fuel mixture. Both mixtures require air and fuel. Otherwise, fuel can't burn without air. Air is the oxygen. Next is CI engine. So 4-stroke CI engine. CI stands for compression ignition. So the name suggests in this case there is no spark plug. Okay. So how this combustion takes place? This is PV diagram. So first let me draw the diagram. Okay. So first the suction 1 to 2. Only you can notice that only in this upper position, there is some difference with the CI engine with the SI engine. Sorry. So from 1 to 2 is suction. From 2 to 3 is compression. Now, in the case of CI engine, the compression ratio, the compression is very high. So, due to this compression, obviously the pressure and temperature increases, and due to this increased pressure and temperature, the fuel automatically burned out. So, in this case, we don't require any spark plug. So, fuel automatically burned out due to this increased pressure and temperature. But here we require one injection, because in the case of SI engine, the compression ratio is less. So in the suction it takes the air fuel mixture, but in this case it takes only the air, then compress the air, then in this 2 to 3 injection occurs, which it injects some fluid particles which burn out, and this is the power stroke. And when this exhaust manifold opens, so 2 to 4 is power stroke, and in 4 to 2, when the exhaust manifold opens, instantly its pressure decreases, and again 2 to 1 is exhaust. So what is the main difference? Here the compression ratio is high. If it is high compression, the first it compress the air only, not the air fuel mixture, but it compress the air. Then at high temperature and pressure, fuel inject. So in this point, fuel injection occurs. So after fuel injection, the inside temperature and pressure is high, so it will burn automatically the fuel, which produces the power in the piston. And then 4 to 2, the exhaust. Sorry, this is not 1, 2, 3, 4, 5. So 1 to 2 suction, 2 to 3 compression. This is 3 to 5 power, and 2 to 1 exhaust. And in this 5 to 2, this is not a stroke. So due to the open of the exhaust valve, the charge pressure reduces, and 2 to 1 is the exhaust stroke. So this is also 4-stroke cycle. Present is very clear. then 2-stroke, then 2-stroke SI engine, spark ignition engine. This portion is not too much important. ProGATE. So in this case, suction is very less. So from 5 to 4, it sucks the air charge mixture. Then from 4 to 1, it compress. So 5 to 4, suction. This is not a stroke. Stroke is the movement of the piston from one end to the next end. So this is not the full end displacement of the piston. Then 4 to 1 is compression. 1 to 2 due to the spark. 2 to 3 is the power, and 4 to 5 is exhaust. So first from 5 to 4, it sucks the air charge mixture. From 4 to 1, it compresses it. So from 5 to 4, the suction valve open, it sucks the air and fuel mixture. Then at 4, the suction and delivery valve are both closed. Then 4 to 1, it compresses the mixture. Then spark occurs at 1. So 1 to 2 due to the spark. Then 2 to 3 is the power. Due to the combustion of the fuel air, it produces some thrust in the cylinder. Then 3 to 4, the delivery valve open. So it reduces the pressure instantly. And from 4 to 5, due to the exhaust of the burn charge. So you can see that in one complete thermal cycle, the piston moves 1 and 2. During this one movement, it covers 4, 5, 1, and during the second movement, it covers 1, 3, 5. So it's the 2-stroke engine.